Okay, year 10, we're just going to talk quickly through a couple of common mistakes people make when they try to draw isomers, or if they're given diagrams and they're trying to decide if they are different isomers. So you need to remember that isomers have the same molecular formula, so same number of carbons, same number of hydrogens, but they are arranged differently. So if you were to draw out the displayed formula or draw out the structural formula, they would not be identical to one another. So common mistakes people make is forgetting that molecules are 3D and that what we draw on the page is not how a chemical actually looks. So to give you an idea of what I'm talking about, I'm going to show a couple of common mistakes people would make. So let's have a quick look. So here we have two molecules over here that are both butane, C4H10, and lots of people would argue that these are isomers of one another. They look different. This one has 4 carbons in a row, this one has 3 carbons and then 1 carbon sticking up here. So this is quite a common thing for people to do, is to draw them going around, what we'd say, around a corner. But in reality, these two are the same structural formula. If we were to write them out, we would have CH3, CH2, CH2, CH3. And then breaking this one down, CH3, CH2, CH2, CH3. They're identical. You can see this a little bit better on the right, where it has, if I hit the 2D to 3D button, it has made both the molecules for me in what they really look like, their real actual shape, if we had some butane. And as you can see, they are both diagrams come out as identical molecules. They look exactly the same. So drawing around the corner does not make a new isomer. So what we have here is basically, that's the most common mistake that people will make, is drawing around a corner and going, oh, it looks different on my piece of paper, it must be different. So a second common problem that we will get is what we call the mirror image problem. So I'm going to show you again 2 molecules that people would draw and say are different isomers of one another again. So both have 5 carbons, both have 12 hydrogens, they're both pentane, but people will say they are different because they look different when you draw them on the paper. Now again, this one you may seem as a little bit more obvious to you. This is just the mirror image of this. We've just flipped it over, okay? And if we put it in the 3D, you should be able to see that they're identical again. So they are exactly the same shape. They're just the mirror image of one another. So they're not isomers. Again, if we drew out the structural formula, we would have in this one CH3, CH bracket CH3, CH2, CH3, and then this one would end up exactly the same, CH3, CH, CH3 bracket, CH2, CH3. So these are not isomers of one another, they are just mirror images. You could take the bottom one, flip it over, and it would look exactly the same as the top one. This happens quite often, sometimes including the end missing one. So sometimes you might get the end missing, end going around a corner, and then draw it the other way around with the end going around the other corner. So making both mistakes at once, they're still not isomers of one another. The final one that people tend to make is when they get really desperate and can't think of the number of isomers they're supposed to have found, is to create molecules that cannot possibly exist. So they are not stable. The hydrogens have more bonds than they can possibly have because they've only got 1 electron, so they can only make 1 bond. Or the carbons don't have 4 bonds, so they're not stable because they haven't got a full outer shell of electrons. But people tend to do this when they get really desperate, just because they know it's got to have the same number of carbons and hydrogens. So they'll try and arrange things so that that matches up, even though the molecule can never exist. So to show you what I mean, these are some examples of ones I have seen before, where people have made sure there are 4 carbons and 10 hydrogens in each, and said this is an isomer of this. Now, obviously, this one cannot exist. It would be completely unstable. It would not be a molecule because this carbon only has 3 bonds, and it needs 4, and this hydrogen has 2 bonds, which is completely impossible because hydrogen only has 1 electron, so there's no way it can share to 2 things. If we hit the 2D to 3D structure on this one, it will throw a little bit of a fit and try and show it to us. So they do look different, but this bond here would break apart. And if you look, it has tried to correct it by putting 3 hydrogens. So let me turn this one, 3 hydrogens up here. So they would not be isomers even if this molecule could exist, because there's a hydrogen there, and they wouldn't have the same molecular formula. Variations on this that you can get, sometimes people will put extra hydrogens on carbons, so you end up with 5 hydrogens on a carbon or 5 bonds on a carbon, to try and make it an isomer. Again, that is not a possibility. Carbon can only make 4 bonds, it's only got 4 electrons. So hopefully when you're working through your isomers, you won't make any of these mistakes now. So keep an eye out, check what you're doing, make sure you're not just drawing a mirror image or just drawing it around a corner. You can accidentally put 2 corners in, so something in a straight line and then in a square like that would still be the same. If you draw out the carbon blocks, it is still the same thing. So watch out for things like that. I will be on Teams for you to check any of your isomers that you want to before you upload them, in case you're worried that you might have any mirror images or corners or things like that going on. Have a good day.